Welcome to Unit 3 Vectors. Today we're going to be looking at Day 1, our Intro to Vectors. So just a simple introduction to what vectors are. If you took grade 11 physics, you should know these already, but just a little recap for what we're going to do. We're going to understand that vector quantity has both magnitude and a direction and can identify equal vectors. So to begin, let's just look at what are vectors. So vectors are designed as a method for describing things that have both a size, that's very important, and a direction. Okay, so you have to have both for it to be considered a vector. Okay, so let's look at a couple examples here. So we're driving 20 kilometers north, can be represented with a vector because we have our size and we have our direction. Okay, the acceleration of an object due to gravity can be represented with a vector. Why? Acceleration would be our our size. And then gravity is our direction. If you know anything about gravity, gravity keeps us on the ground, so it's going to be pulling us down. Okay, so we're south. Okay, you will hear, rather than size a lot, you will hear actually the word magnitude. Okay, so when you're asked to describe like the magnitude, that is the size. So if it's 40 kilometers an hour or 10 newtons or whatever it is, that is what they mean by the magnitude. Okay, so those are important to write down, some important definitions there. Another thing that you want to write down is the difference between vector and scalars. Okay, a vector is a quantity having both our magnitude, so remember that's our size, and a direction. Scalar is a quantity having magnitude or your size only. Okay, so there is difference. So to be considered a vector, you need that direction. Okay, so we'll look at a couple of examples here. And you're just going to try to figure out if you can figure out if it's vector or scalar. Okay, so you are 5 years old. Okay, so if you're looking at that, you're looking for both a magnitude and a direction. Well, we have a magnitude, we have a size, but do we have a direction? No, so it has to be scalar, okay, because we have no direction. What about you're traveling 60 kilometers an hour? Well, we have a magnitude again. But do we know which way that we're traveling? Nope. So we have no direction. So again, it's going to have to be scalar. Okay. So go to third example. You're traveling 80 kilometers an hour east. Well, we have a magnitude. And this is our direction east. It would be direction like this. Okay, so we know that it is a vector because it has both magnitude and direction. Okay, there will be lots of those in your homework, so just write those out and just practice with that as well. Okay, so we're going to actually look now at what a vector looks like. We know that it has both a magnitude and a direction, but on paper, what is it going to look like for us? So let's just read this here. So a vector is represented by a directed line segment. Okay, so it has a beginning and end and an arrow on it. So it could look something like this, or like this, or like this, or like this. There's multiple ways that a vector can look like, okay? Just need to make sure that you have the beginning, okay? It's straight and then has a end to it with an arrow on it. Okay, key thing here is that the directed line segment has a magnitude or a length. Okay, we could write like this is 1.5 centimeters if we actually measured it. Okay, and a direction that's indicated by the arrowhead. So the arrowhead is pointing up here, so that would be north. Okay, so you just need to make sure that it's always indicated by the arrowhead. It's not going to ever be by this end, which is called your tail. Okay. So for an example, here is our coordinate grid, but we have labeled it with our directions north, east, south, and west. A way I remember that is never eat sour watermelons. I'm sure you've been all taught your own way to remember that, but that's how I remember it, okay? Just need to make sure you're labeling it correctly. And then you would put your arrow. There is an arrowhead there. It's kind of covered by my writing, okay? So you have your line segment, your directed line segment. It has a beginning. It has an end with a with the head on it, okay, an arrowhead on it. So then you need to you would need to label it with a magnitude. And then it was the direction because it's on the coordinate grid, and we can read that is going to be between between north and east. Okay, so this one we could describe V, so that's the way that we're describing it, our vector. And you'll notice that it has like this little arrow over top of it. You need to write that, okay? So you're going to do V, and I draw it like this, or you can do V with an actual full arrow on it. It doesn't matter, but the direction that it's pointing does matter, okay? So because we're pointing to the right, it has to be like that, okay? You could describe the vector, or the V, as a train traveling at 15 kilometers an hour due northeast, okay? So you're going to read always from the north or the south first, all the way to the east, okay? And that's the way that your textbook answers are as well. Remember, for it to be a vector, it has to have that magnitude and that direction, okay? So that's your scalar component, which is the magnitude, and then your direction to make it a vector. Okay, so there's one example. Suppose we are given the following vector. So we're given our vector A, B. So we're starting at A and we're ending at B. Some terminology here is just that this A, because it's where you're starting, is going to be called our tail. And the B, where we're ending up, is going to be called our head. Okay. So for notation for this, you can write it as AB, because you're starting at A, finishing at B. So starting at A, finishing at B, and you're going from A to B, so that's why the arrow has to face that way. Or V, because you've labeled it as V, would be acceptable notations for the vector. Okay. However, AB and the arrow the other way is not acceptable for the given vector because the arrow is not going this way, okay? It is not going that way, so you cannot draw the arrow backwards, okay? As well as nor is BA, okay? So it is the same magnitude, but the direction is different. So this vector would actually be BA, right? You'd have to label those separately, so you're not allowed to label it for the given vector up here, okay? For describing a negative vector, we have our same vector here, A, B, and then we could label it as V. It could represent a car traveling at a certain speed northeast, right? If you were to draw that, we'd have north and then east, and then you put that on there. Okay, this is A, this is B, or this is V. Okay. Then negative V is a car traveling in the opposite direction, southwest. Okay. So that would mean that it's traveling opposite. It would be going this way. Okay. That is going to represent the negative of it, okay? It's opposite direction, southwest, but at the same speed or magnitude. So your notation here would be AB is equal to negative BA, okay? Notice the arrows are the same way, okay? We have just put a negative out front and we have flipped the direction that it's going, right? It would be going the opposite way. Okay, but remember, because our magnitude or our speed is the same, the absolute value, that's what those straight lines are, they have to be equal. Okay, but our direction is opposite. Those arrows, you draw them in the same way, but you put that negative there, and you are going to put them in reverse. Okay, thus V and negative V are opposites of each other. Okay, so it's just opposites. Opposite means opposite direction, same speed, okay, or magnitude. Okay, What about equal vectors? So we looked at negative vectors, we're going to look at equal now. So 2 or more vectors are said to be equal. What's this stand for? If and only if, okay, so it wasn't a typo, if and only if their magnitudes and directions are the same. So you can have 2 vectors, but they have to have the same magnitude and the same direction to be equal, okay? So let's say we have vector v and vector w, okay? They are the same because they have the same direction, okay, right? Both arrows point in the same direction, northeast. Magnitudes of magnitude of vector v equals magnitude of vector w. Okay, you can see that they're the same length. You could measure them if you wanted to be exact. Okay, so therefore you say the absolute value of v is equal to the absolute value of w. Okay, thus v is equal to w. Direction has to be the same, magnitude has to be the same. Okay, you can also state that v, those 2 lines, is parallel to w. So the 2 vectors are parallel. Okay, so we can state all of that for this, for these to be equal. Okay, some notation here. Can vectors be parallel but not equal? Okay, can they be parallel but not equal? Obviously, yes. Okay, so we can be parallel. Are those parallel? Yep, they're going the same direction. They're parallel. Okay, however, are they the same magnitude? Nope, like this one's really tiny, this one's a lot larger, so they aren't the same magnitudes, so therefore they're not equal. Okay, but they are parallel. Can vectors be equal but not parallel? No, because remember, for them to be equal, they have to have the same direction and magnitude. Well, if they don't have the same direction, then they can't be parallel, okay? And that magnitude as well, okay? So make sure that you understand that they can be parallel but not equal, but they can't be equal but not parallel, okay? So let's look at an example. So here are lots of different vectors. So we have our rectangle ABCD, and it's labeled there for us. What we're going to do is do some examples of finding different vectors, okay, given a diagram. So give 2 vectors with equal magnitude. So we need them to have the equal magnitude, which means equal size. Okay, so well, why don't we do BC, that's our long one on the top, that's just the first one I saw, okay, is equal to, and then if we look here, we would look like it's like AD, and technically those are the same magnitude because they're in a rectangle, right? However, look at the way that the arrow is drawn, okay? You want to get used to stating that vector from the tail to the head. So it is equal to actually DA, okay? So make sure that you're stating it starting at the tail and then ending at the head, okay? You could have also done like AB is the same as CD, okay? That is fine as well. Can you give 1 pair of equal vectors? Remember, equal needs the same magnitude and direction. Okay, so let's go with AB. So A, B, that's just what I'm choosing. Okay, is equal to A, B is equal to what? Well, you need to write CD, right? Because they have to have the same magnitude. But is this arrow going the same way as this arrow? No. So we're actually going to have to write it as negative CD, because remember that negative is going to be your opposite vector, okay? So because of the arrowhead being the opposite way, you just have to write it backwards, so that now you know that it is CD, but going this way, okay? And then can you give one pair of opposite vectors? Well, let's go with BC again. Okay, so BC is going to the right, we end at RC. Okay, and then you want to go the opposite way, so we need the same magnitudes. It's got to be DA, and since DA's head is going the opposite way, you can write it as DA. Okay, so there are actually a couple, like you can have like a couple different answers for these ones. I just chosen to show you one of those, okay? So don't get confused on that. You could have chosen two vectors with equal magnitude. We did the BCDA. You could have done the AB DC one as well, okay? So you can go like opposite of ones that I have as well. Okay, so that is it for our intro lesson. Lots of homework there. In the homework there is lots of is this scalar versus vector, blah, 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 blah. So just let me know if you have any questions with that. This is an important lesson and important homework to understand, as it's like the base for our next 4 vector lessons. Okay, good luck. Let me know if you have any questions.